Welcome everyone to session 4 of the Tephra Fusion 2022 workshop series. This is the last or final session that we have set up and planned. And today the intent is to try to get a better understanding of the community needs, sort of take the pulse of the community, so to speak. And I'd like to remind everyone that we are posting recordings and Q&A for all of the sessions to the Tephra Fusion 2022 workshop website. And the first sessions are live there already, and we'll be getting the rest of those up in due time. And this session, to start with, we're going to do a little bit of a recap on some of the motivations, and then we will try to get community feedback and tie all these things together. We're going to be using some Google polls to get your input on a series of questions. And this session is being run by 4 co-hosts, and we have a few of the previous panelists here also to help out. And so Christy, Marcus, and I will be handling most of the presenting, and Andre and Jenny and some others will be kind of helping out in the background with some of the logistics and trying to help things move along smoothly. And again, we have several questions that we'll get to throughout this session. And when we get to the first one, we'll post a link to a Google poll. And for that, the feedback will be anonymous unless you explicitly type in and add your name to your response. You're certainly welcome to do that if you wish, particularly if it's something you would like to have some follow-up on and communication on. And for a lot of these questions, you might find that you have more than one idea to contribute. And for that, we ask that you submit the form multiple times so that we can keep each kind of idea separate. And also, we're expecting that there'll probably be more than one person who may have some of the same ideas. And so having those repeat submissions of the same ideas by multiple people will also actually be really useful for this, because then we'll be able to get a sense of which kinds of things are most important to the community, which challenges or issues are most common, and that will help with, I think, having the community maybe prioritize what some of the next steps might be and what order we might want to tackle some of this. So what are we planning to do with all of this? The idea is going to be to share the feedback that's received with the community. Of course, there'll be the recording of this, and we'll have the notes and the feedback that's received. We'll post that to the website. We can also put things on VHub. Some of the materials from the previous workshops, like 2014, 2017, and so on, are on VHub as well. And of course, the best practices themselves are on Zenodo, and we can add to that set of documents to incorporate the community feedback as well. We can also use this input to improve on those best practice documents that are on Zenodo. We can use them to improve on some of the initial implementations that we saw in session 2 and session 3. The feedback can also help us with developing new systems and improved systems to better serve the needs of the community. So again, most of this input will be through the Google form, and we will also have some time for discussion. If you run into any technical issues with trying to submit ideas through the Google form, you're welcome to put those into the Q&A instead, or to email those to any of the conveners. And we'll be happy to incorporate and put all of the different forms of input and sources all together. When we have some time for discussion, it is possible if you raise your hand, if you happen to want to speak, we can make it possible for you to talk. Again, if you want to contribute to the discussion times through Q&A, that's fine as well. But mostly we'll be using the Google poll as the mechanism for input.
Okay. All right. Thanks, Steve. Welcome, everyone. So we wanted to kind of start off with a brief overcap of motivations for the workshop that we talked about in session 1, but we'll talk about again here just to kind of help seed thought for moving forward. So Tephra studies are interdisciplinary and global, and the deposits themselves form a common thread that connect multidisciplinary researchers who share overlapping research needs. So here's a really terrific graphic showing the wide variety of disciplines that share Tephra, including things like volcanology, paleoclimate science, archaeology, paleoseismology, atmospheric science, health sciences, and so many more. But Tephra studies are also challenged by the lack of standardization that prevents comparison amongst various regions and across disciplines. Next slide. Thanks. Tephra data are stored in disconnected databases and offline files, limiting their access. So listed here are a whole variety of examples of the many forms that we find Tephra data in, from regional databases, Antarctica Tephra, East African Rift Tephra, Alaska Volcano Observatory's GeoDiva. Tephra Base are just some examples. Some big data repositories, EarthChem, New Zealand's Pet Lab, Smithsonian Global Volcanism Program. Sometimes they're just files on individual people's computers or in their labs. Sometimes they're simplified figures and tables in publications. Sometimes they're publication supplements. In theses, things like that. So they're just really all over the board and hard to access. Next slide. So I'm not sure, but I'm betting that this rings true for many of you, but beginning in the 80s and through the 90s, advertisements on milk cartons in the United States were used to publicize cases of missing people. And in the current state of tephrochronology, haven't we all thought of our tephras kind of like this? You have a bunch of data and you can't figure out what it correlates to. So you go hunting for this and you feel a little bit defeated because of the disconnected nature and general inaccessibility of tephra data. So this kind of makes me think of that vision. Next slide. So the next couple of slides, we just want to give some good reminders or examples of why creating comparable data sets is really important. So in this example, Britta Jensen and 10 other authors combined geochemical, age, and shard morphology data to show that the White River ash east lobe from Alaska correlates to the 1860 B tephra found throughout Greenland and Northern Europe, with a distribution of over 7,000 kilometers. So you can see here the map distribution is quite small. I don't know if you can see my mouse, is quite small compared to where it was actually known to be distributed. So these data sets link marine, terrestrial, and ice core records collected really from various workers from various different disciplines and at different times. And these data show that even moderate eruptions have greater distributions than previously thought, aiding to modeling and hazard assessment. Next slide. So here's a couple more examples of how tephra collected from different purposes were used by volcanologists to better understand some basic but super important information about eruptions and how tephra particles are distributed in the atmosphere during eruptions. So this map shows a whole variety of study sites in red, all the red dots, and they're collected for different reasons from different people at different times again. And the data were put together to yield new results. So Kathy Cashman and Allison Rust used data from well-characterized eruptions, so things like deposit maps, satellite observations, distal mass, and transport distance. And they showed that 10 to 20% of erupted mass lies outside the mapped limits. And from this, they can conclude that cryptotephra data can be incorporated into volcanological studies of ash transport and deposition and provide really important insights into both the behavior and impacts of far travel volcanic ash particles. Where another study where Celine Pouget and others used data from published sources concentrating on different disciplines, tephrochronology, paleoclimate, and paleomagnetism, as well as paleoseismology, to create isopac maps for 2 large eruptions in the Western US. So this is up here, the Trago Hot Springs tephra from Mazama and the Rockland tephra from the Lassen Volcanic Complex that otherwise had not been characterized in terms of physical volcanology. So these examples illustrate how important it is to generate comparable, basically apples to apples data sets and also to help us to think outside of our own research boxes and see the gold mine in the data in making the data available for multi-purpose reuse or multidisciplinary reuse. Next slide. Okay, so here's what we've heard from the community since the 2014 workshop and where we're at in this process. So starting at the bottom, we all agreed that the foundation to good tephra studies and the precursor to building better systems is to first standardize how we collect, process, and analyze tephra. And so we focused these efforts in the last 8 years since 2014 on this very foundation through the development of the best practice guidelines for tephra collection and characterization in order to build comparable data sets and better documented data sets. And that's what we shared in session 1. And then a couple of implementations of those in sessions 2 and 3. So the next step 2 there is to build fair data systems and upload our data to those systems. And this will make them findable, accessible, interoperable, and reusable. And in session 1, we had talks from a major funding agency, the National Science Foundation, a major journal, the Nature Science Data, a large data repository, EarthChem, as well as from the USGS, who all emphasize the importance of standardized fair data in both the present and the future. And the final step 3 here is to connect these tephra data across all of these systems and make them more globally accessible. So we're really living in a good time for this right now. The technology is there. We just really need to decide what we want. So the hardest part is just clearly defining what is needed and trying to get there. And this requires deep community involvement, and that's why we're here today. And so we're hoping to get the pulse of this community to help us reach the next steps and towards those next goals. Next slide. And then Marcus is going to be working here.
Yep, thank you, Christy. And so, hello, everyone. We wanted to get into the question phase of this presentation, where we're going to sort of take the pulse of the community at this point in time, see where we are, how we've progressed, and where we're going, and check on whether the tools that we've come up with are of any use to anybody and are envisioned to be used by folks. So we wanted to start with just trying to get an idea of what people think are the current roadblocks to what we're trying to head towards, and then sort of future directions, and then get more specifically into the tools that we presented and similar tools this time. So what we've heard recently as far as roadblocks to moving forward are the following. That tephra data are multi-parameter. They're both physical and chemical types of data. They take a long time to process, analyze, interpret, and correlate. So it's a big process to get these data together. And as you can see from the examples that Christy presented, that it's quite a long process using legacy data in particular. Slow publication of data. The reward systems are not really valuing data publication, and yet it would be good to value data publication if we wanted to be able to be more willing to share data. The biggest problem with that, according to both the NSF and according to Guy Jones with the scientific data from Nature Publishing, is the fear of being scooped. So people have a real fear of being scooped if they put their data up somewhere publicly available, and those data get used by somebody else. Another roadblock that's still there is there's not widespread adoption of standard practices. We've put up our guidelines, and hopefully those will begin to be useful. We do need comparable data sets if we're going to be able to share more. We need to make sure that data repositories can handle the specifics of Tephra data, and we've ourselves have worked with the EarthChem to try to do that. And what other ways are there other problems with that still? One thing that gets down to the individual investigator level is the culture. We haven't really incorporated into our own workflows that making data fair is just a regular part of the workflow that we should be doing, and it should be a natural and easy thing to do. Another roadblock to people sharing more is that people are actually unaware that their Tephra data are of value to other people in other disciplines. And we've tried to reach out to as many disciplines as possible. And a lot of times we're surprised by somebody will come up to us and say, hey, you never asked us about this kind of stuff. And so we continue to be surprised by how many different disciplines use Tephra data. So we need to become more aware that our data could be useful, and other people would like to have access to them and be able to potentially use them for their needs. And then another big roadblock that folks have mentioned lately is that we have global data needs with Tephra data, or very large synoptic scale needs, but we only have local research and funding environments in our different countries. So those are the kinds of things we've heard lately as far as roadblocks go, and we'd like to open that up to questions right now. What are the roadblocks to moving forward? And we're doing that. Steve, could you move to the next slide?
Yep.
Yeah, by using Google Forms. So the way we're going to do that is you should have been sent in your chat a link to this Google form that Steve is showing here. We wanted to point out, notice that it does show an email address there. We're not recording email addresses. This is done completely anonymously, so you don't need to don't need to worry that your email is going to show up. However, if you want to include your name in your answer, just so that we know who answered that, you may do so, but we're not recording the email, so just so you don't worry about that. In terms of how to fill out the poll, then if you can go to your chat, you should see the link, and we're going to go through 8 questions, and this is question number 1. So in the first blank there, you'd please type the question number. You'll see the question number. You'd put the question number there. Thank you, Steve. And then you type your answer below that, and then you hit the submit button. It's okay if you submit the same responses that we just I just talked about, the things that we've heard lately as far as roadblocks. You can do multiple submissions if you think there's multiple roadblocks. Please put those in. If somebody else already put an answer in, it's okay to put that same answer in again, because that will sort of get a slight, a very informal poll on what people are thinking lately. And let's see. And if you want to use your native language, you don't feel comfortable in English, you feel it can be expressed better in your native language, go ahead and do so, because we will run it through Google Translate. Hopefully we'll get that right. And those of us who know a few other languages, we can try to translate. Okay, so that's how that poll is going to work. And so submit as many responses as you want there. And we'll be recording it. Steve, could you go to the spreadsheet? So these will be automatically recorded here on the spreadsheet. It looks like we got some answers already. And so people are already filling it in, and that'll just keep populating as we go along here. I'll try to, in real time, put these answers together and summarize on the next slide. So Steve, could you go back to the slideshow, please? And we'll do the same process for all the questions, and hopefully we'll get some kind of consensus on where the community is at this point in time as we go through this process. Thank you.
We're going to give everybody a little bit of time to process this information. So do not rush. You have a couple of minutes to do that.
Yeah, please feel free to think about it a bit so that we can, so that you can make sure your answer is what you want.
There's a question in the Q&A about seeing the roadblocks that were already proposed in the slide presentation. Is it possible to share those? Thank you.
when we originally planned for the answers, we didn't expect that we get such a good feedback. So we probably should move to the next question now. And Marcus
Okay.
will summarize what we have now
Yeah.
for question 1. Otherwise, we will
Steve, could
never
you
finish.
show the current poll results? And folks, if you keep thinking of answers to question 1, you can keep putting in question number 1 and another roadblock if you think of it as we go along. That's fine to do it out of order. Yeah, back to the slide, Steve. Thank you. So this is roadblock responses. Yeah, that needs to, that should be updating.
Refresh it.
See if I can refresh.
Yeah.
Yeah, okay. Question 1.
Slide before that one. So it looked like, from what I could see so far, time. Actually, I think that was one of the answers specifically. Just the time it takes to add this to the workflow. And we did have sort of some thinking on that. That it just needs to be part of our workflow somehow that is natural. And if we have the right tools, that time thing would maybe be diminished. But other people mentioned, having the ability to use the personnel's time for this kind of activity. There's a lack of rewards for data sharing. There's the fear of being scooped was very big, it looked like, especially for beginning investigators, coupled with inconsistent or non-existent embargo or data security concerns. And I think that would be a sort of a top-down thing. There's lack of standard data collection, processing and reporting was another big thing that people were mentioning. The lack of the consistent consistency in GLASS standards was mentioned several times. And then easier ways, better tools perhaps to upload so much data. Thank you. Thank you, everybody. Steve, let's move on to the next slide. So let's try to move on to the next slide, and this will be related to question 2 then. Again, here's some, this question 2 is about future directions in resolving the roadblocks. We've already gotten some responses from folks, so we're putting these up here. Again, if these seem important to you, please add them to the question question responses as you wish. So first one is the one obvious thing is to have widespread adoption of the best practice guidelines, perhaps the ones we put up on Zenodo, but if something else is better, that's fine. We do need a better computer infrastructure. It needs to be more user-friendly for folks like us who are more concerned with the science than with trying to manage computers. Getting the data into repositories, the templates need to be or could be modified to make that an easier process, and hopefully the work we've done with EarthChem might help along those lines. The systems do need to be fair, that's findable, accessible, interoperable, and reusable. Big thing would be to update institutional reward systems to consider the importance of data, and long-term related to that is a long-term support of the data repositories and individual investigators to be holding on to the data or somehow storing the data on the longer term. Also related to that, making data have greater importance is seeking funding or making it possible to seek funding to digitize legacy data or do data rescue. Current methods demand justification with new research questions, but can it be done based on not having an imminent research question? And then Another possible future direction is to continue to develop community projects and pathways that support collation of legacy data and new user data to answer important research questions. Good example of this is a current USGS postdoc that's working with the AVO and Christie, Alaska Volcano Observatory and Christie to use their legacy samples and new data and to develop correlation tools based on those. Another potential neat community project might be something like looking to develop a database of the largest marker horizons around the world. And then another one would be a list of samples from large eruptions. Who has what? And could those data be stored somewhere? Just who could be talked to about certain events? Next slide, Steve. So the question number 2, so on the question sheet, the question number 2 is, what are your ideas for moving forward, and what does the Tephra research community need at this point? What things could we be doing to keep moving forward on these issues and going in the right direction? So here you'd put in question number 2 and an answer to how would we move forward to make data sharing easier and or increase the fairness of data, or make it more possible for us to work together to answer some big global type questions that we can't currently answer, or answer questions about particular tephras that we find, the lost tephras that we can't identify, and because we're just not able to connect to the right researchers. How can we move forward on those issues? Again, we'll wait for a while for answers to come in. Please use the questions that the responses that we already have put up if those seem important to you. Add however many times you want, same as question 1.
Anyone from a panelist want to add to these possible solutions? That might be a good time if you're not typing.
Oh, I'm happy to. This is Kirsten.
Good.
I think they're really good ideas here. I just put actually a comment already into the question answer thing about these legacy projects. I think they are very doable, but need to really ensure that the rescued data goes into these long-term curated collections and isn't just a spreadsheet that's put up somewhere, gets integrated. I wanted to just comment on that last line of list of samples from large eruptions. One of the big obstacles that we found in previous work with the volcanology community is the fact that samples are not, don't have the metadata to which eruption they belong. And a really difficult effort to go back through existing samples in the literature and kind of tag them with eruptions that might be in itself a sort of data rescue project, just to figure out how we can link more samples to volcanic eruptions and not just to volcanoes.
Thank you. I also had a question to NSF. For example, what we discussed in the community, this idea that it's very hard at the beginning when we're creating a data management plan to figure out how much data actually we will have and how much time we will need. So in a way, it's a data management plan. It's obviously our commitment to share data. But what do you think of potentially like having some supplements to the grants where PI already know at the end how much data they have and they can guesstimate time, I guess, how much they're going to put into making data fair and publicly available and submitted to data center. So that's kind of was a question that we had in the community here.
Yeah, I can try to answer that. So from the NSF perspective, it's important to know that the data management plan is one among many parts of a proposal. And we view a proposal as just kind of the initial phase of a project. And we understand not just with the data management, but with many other aspects of research and broader impacts that plans can change as you actually get into the work is inherently unpredictable. So I think one paradigm that can work is you have your data management plan that's part of your proposal, but then you might separately have your data management plan that you share with the data facilities that you're working with for data deposit. And that could potentially be a living document that evolves through time.
Thank you.
Yeah. Another thought here is trying to make it so there's less work, right? The time, work has come up. Can we make the process just inherently less work from the beginning? And I'm thinking the example of StravoSpot is a great one here. So now instead of putting data in field data in a paper notebook and then having to spend extra time to transcribe it into some way that could go into a repository, you put it into an app, and it, by the design of the app, it goes into a database already transcribed, already digital, already with some of the best practices built in. And then from that point, sharing with others is trivial, no extra work. Is that model something that we could apply to much more of the workflow?
That's the same with registering samples. You know, if you do that in the field, your sample metadata is always available.
Yeah, one thing I wanted to answer or add to that with StravoSpot is, yeah, it's easy to collect all the metadata with it because a lot of the metadata you want is sort of automatically generated. The other thing I'll say with StravoSpot is that you do have a public-private option. From what I've seen in the questions, people are worried about embargoing or not showing their data. You can keep your data private as long as you want. Once it's published, though, you know, it should be available for everybody.
I guess that quite often NSF requires 2 years from you know, finishing of the project. You have to release the data, and quite often, like in you know, time-consuming projects like ice cores, marine cores, quite often you just way behind the schedule, and you still have to release your data. And quite often other people have access to these data sets in repositories, and they publishing. And I think it's an easy solution to address, actually. If somebody wants to publish your data, they should just make you first author on the paper if they can't wait anymore. And that's an easy solution. For example, something like this. So as a community, if we develop this, you know, culture of sharing and culture of referencing data, we might be just okay.
One other thing I'll add with that is that with StravoSpot, the collector and the owner is inextricably linked to the data. So there's no way to take somebody else's data and make it your own. Everything is uniquely time-stamped and located. So if you do use data, that data carries the generator who uploaded it as well, which I think is an important thing.
Yeah, I just want to follow up on what Andre said. In the Tephra chronology community, I think we're quite lucky in that it's quite collaborative and people work together quite closely, and I would say generally are quite respectful of contacting each other when it comes to using data. And I do think there's something to be said about culturing that data usage. And, you know, just a thought would be, it might be helpful to outline a little bit of a best practices for using available data. Just, you know, what should you do? Like if there is a data set that's available that the author very clearly has said that's not published yet, you know, and if you want to use some of that, what should you do? Because, you know, a lot of us would know automatically, but a new grad student or researcher might not know what I guess is the most polite and respectful way to use data publishing. And if you can create that community of respectful data use where the authors are properly recognized or involved in a project, then hopefully you can get rid of some of the issues around fear of data sharing.
I put a comment in earlier into the chat about data citation. It is unfortunately not fully implemented in the literature, but any data set that is formally published and has a DOI needs to be cited when it is being reused. So, I mean, anything that is not published should probably not be used without getting permission from the author, the owner of those data.
What also happens sometimes, somebody would write a paper and use, let's say, 20, 15 different data sets in the paper, and that paper gets cited a lot. And quite often the original data sets, they are not actually getting a credit for this work. Right. So we have to address this as a community also. Maybe create like a text file where we're listing all included data and always reciting them, something like this.
Yeah, we have actually, I mean, this was from the very beginning of the PetDB database. This was an issue because in the meantime, it's hundreds of publications that people use when they, and sometimes the whole database when they actually do statistical analyses of the data. And it is basically impossible right now to cite 2,000 original papers, right? But there are increasingly solutions at least suggested in publishing packages of these references. How they will enter into anything like a citation index has not been solved yet.
That's an important problem. Also with EarthChem, as you pull data out, you can generate a list of citations. So it's not like you have to, type in 2,000 citations. You can just automatically generate that list out of it for samples you're using. I guess the other thing just to mention is that a lot of these things that we're talking about can be addressed too with increasing interoperability between the systems. That's our goal, is to make them really interoperable, but just finding the time and resources to do that takes a bit of work. But I think on the
a bit is a little bit of an understatement.
A little bit of an understatement, but I think the statement from this group that you all work collaboratively, that's how all the data systems are trying to work, but it's a little more complicated, putting it mildly.
If anybody from attendees want to speak, put it in the questions or just raise your hand and we will promote you and we will allow you to speak if you just want to say something. Thank you.
Yeah, I just want to kind of follow up with the time issue. In our lab, when we produce enormous amounts of geochemical data, but we have a system where when a student starts a project, they have to start compiling their data into a central, essentially supplementary data set right away, right from the start. And I think, if you incorporate kind of the minimum workflow into I guess the minimum best practices. And I think this is an important thing to point out. We have these incredible best practices templates that have been produced by Christy and everyone else, but, and they're huge, but there's kind of a minimum amount of required data. And if you can maybe create a template that's just that minimum data, and then when you start working right from the beginning, you are compiling those. So, and at minimum, when you publish your paper, you publish that as a supplementary data set. Maybe you upload it to Zenodo so it has a DOI right away. And I think one thing that really needs to be emphasized here is we as a community are going to be reviewing these papers. We're going to be reviewing these publications. So if we're really serious about making sure that we foster this community of fair data, of making sure that people are actually following through with minimum standards of making data available, using standards, reporting standards. As reviewers of publications, I think it's up to us to be aware of this and I guess putting our reviews where our mouths are and enforcing that within the community.
Neat. That's a really good point. Enforcement. Should we go over the responses that I've seen so far? Or at least I'm going to try to summarize here a little bit for now on question 2. Steve, could you go to the, I guess it's the next page?
Yeah, I'll have to, if you want to see it updated, I'll have to exit the slideshow and refresh.
Oh, okay.
Let's see. Yeah.
Oh, that's it, actually.
Like it's
Got
done.
it.
Okay.
Yeah.
I just
that's-
apparently just need to exit the presenter view and then I can go
Then
back.
it can do it, yeah.
Yeah.
Okay, again, this is sort of a very informal, quick consensus. Folks want to continue the development of long-term central data repositories or interoperability of current repositories, smaller regional repositories. That's a big issue. A neat idea that I saw, I wanted to put it up here, a database or a community site or a community project for folks to share lost Tephra. So I guess the idea was some site where you could go and just say, okay, here I have these data. Does anybody know what I'm looking at? That would be really interesting. A number of places, a number of folks mentioned one web page to show how to get the data into a repository following FAIR principles. And we've made an effort at that and tried to do it. That's the EarthChem Tephra community page. And I show the URL there for that. If there's some improvements that could be made in that website, we would really love to hear about it and implement any improvements that could help us. Another big thing more on the scientific end is just use and include in the publication secondary standards. That's a basic thing that should be done. Another idea that was interesting idea for a community project was to make a site or a project where different Tephra samples were linked to source volcanoes. That would facilitate the linking of Tephra chronology, archaeology, and other endeavors that concentrate on distal Tephras to the volcanological community. And then another thing that people mentioned a number of times is just stop, and this is, again, I just copied how one person put it, is stop reinventing the wheel. Use tools and databases that are already out there. And again, is it EarthChem or something like EarthChem or EarthChem-like implementation in another country, what we're seeking. So those were some of the great responses that we're seeing there. And again, keep putting in responses. Just put in the question number 2 and your answer if you think of something else as we move along here. Next slide, Steve.
All right. So this question is it's my turn now, I guess. we made notes to ourselves to keep track of this. So on to another question. We do have several others to come. So question number 3, how do we get wider adoption of the best practice guidelines? I think some of this has come out in some of the discussion already, but we probably haven't captured everyone's ideas on this just yet. And so, yes, how would we get wider adoption of the best practices? And from an more individualized standpoint, how could your own laboratory or your own workflow, your own students, or and so on, or maybe you're a student and you're developing your career at this point, how could this best practice framework be implemented into what you do? And again, we'll have responses. We'll have the poll. We didn't put the little pictures in here, But again, you can go put in question 3 and then add in your ideas and thoughts, and we'll see. We have a few starting to come in already, and we'll do a summary. I guess others, Marcus, and would you like to do the summary slide again? Well, since I'll be stuck in the presentation.
Yeah, I'll help to do that as
Oh,
well.
Okay.
I'll
Yeah.
just be pasting things in there, but yep.
Okay. All
That'd be
right.
great.
Yeah.
A couple of us can do that.
So back to the question.
So this question is specifically about the best practice guidelines that the group has put up on Zenodo. If you aren't aware of those, let us know, and let us know that those haven't been advertised well enough, or anything like that, or if there's any other problems that you see.
I just wanted to add, I have in any presentations I give, I have a slide of a list of publications about best practices for data. And I always see audiences writing down that one of those references to go there. So there's a lot of outreach to be done, but if everybody kind of gets that into their message in lectures and talks, it helps a lot.
One thing that I could offer that some of the other communities have done on best practices is with StravaSpot, when we work through with other people, they have fields that are required, recommended. One of the reasons we get a lot of uptake for StravaSpot and field camps is the way the menus and the way the pages are put together. It leads students through making field observations. And it's easy enough, I think I said in my talk, to put together a specialized Tephra page. It's kind of scattered around now to fit in, but you could customize that and enforce best practices to some extent by required fields. You can also just put out options so that people know what sort of data they should be looking for, and maybe not forget to make observations on particular aspects.
some of the panelists might have to leave early, but we can forward you questions if you have some specific questions addressed to the panelists from any previous session. Just email to the work group, or we can forward it for you. Thank you.
I saw the question about easy, accessible, applicable, and again, that's something we can really strive for on the data side, to help lead people through observations. Sounds like this person was asking precisely what we like to do.
Yeah, I like the idea of including, oh, Steve, you're going to go over these in a minute, I think. But along those same lines, Doug, you know, using Strabo in Field Camp and making a tool like Strabo that automatically eases the sharing of data, the standard in Field Camp would get people really in mind of doing this at the start of their career, and that seems like that could be a big thing.
At UMaine, we're teaching Strabo in a field methods class since last summer, and students attended actually Strabo workshop that Doug was running at the same time. It was really, really helpful.
Perfect. Yeah.
Yeah, we have a lot of things up on YouTube, how-to videos that you can go to and explain different things. And I've been talking with Marcus here. We're just about to release a new version onto Android soon. Hopefully within the next month, we'll have that out.
So yeah, we got, I'm still impressed that the number of responses and feedback we've been getting. This is just outstanding, truly outstanding. Thank you, everyone. And so this is a summary of some of the major points. And yes, training is a big one. We need people to feel comfortable using these tools, and training can really help the community get there. And following on that, workshops at major conferences. I'm happy to add that there already is a workshop planned for the IABC meeting next year in New Zealand. And there will be more information coming out about that sometime later this year. And we have templates for field and lab suggested, ongoing advertising and getting the word out so more people are aware of all of these various kinds of tools and templates and everything else, the whole ecosystem of things to help make this happen. Simplified versions I imagine will probably be helpful for initial training and saving time. Sharing more examples, that can be also really helpful for training to see how someone has done this before. We do have a few of those, but we could certainly use more worked examples. The existing worked examples that we have aren't comprehensive for every kind of Tephra data, and it would be great to have the community fill in some of those gaps. I like the idea of working with the instrument manufacturers. Some of these systems don't output some of the metadata that we would need to go along with the data, or like SEM images and things like that. Some of them do better jobs than others, and it would save a lot of time if people weren't saving let's say a JPEG file and having to type in what the magnification was into a spreadsheet. It was just all happened natively. Reviewer awareness, and part of that would be building on the training and the advertising. And of course, yes, funding for developing additions that we need to extend all of this. I'll move on to the next slide. Christy, can you take over?
Yes. All right, moving right along. We're about a little over halfway, and we're on question 4. So I think we're going to make it. All right. So the next question is based on a tool that was shared in session 2, StravoSpot and StravoSpot Micro. And so we're just trying to gauge whether or not you see yourself using these tools or other field applications or similar tools. So if yes, how do you envision yourself using them? And if not, why not? So just recall this was presented by Doug Walker and a couple other folks during session 2. And it was just an example of how we worked with them to integrate the best practice guidelines into an existing field collection tool. So this was to help aid researchers in the field. And so we just want to get a sense of whether or not you think that this is a tool, or the idea of using tools like this to adopt the best practice guidelines into your workflows is something that you would consider. So we're just use that poll again, write down question 4 and just give us your thoughts on how you think this is going. That was a really successful workshop. People seemed very excited about it. We also know not everyone was there at that workshop. So anyway, if you can just kind of give us your sense of that, that'll help us. And also Doug is here now, and so he can be seeing some of these comments, but we'll also be forwarding any of your thoughts and comments on to StravoSpot to further develop their tool. So have a go at it. Doug, if you have anything to share here, feel free, and we'll be compiling this into the next slide. Or anyone else.
So just one quick thing on a couple of these questions. The dollars for tablets at this point, our user base is really iOS centric, but like I said, we're getting things out to Android soon. You can still use version 1 of StravoSpot, which is available for both Android and iOS, and it runs on any phone or tablet. So if you have a phone that you would use with fieldwork, you could use that. Eventually, and depending upon level of funding, we'll be doing the newest version down to phone at some point too. But that's we did a survey of users. 90% of the registered users use iOS and a tablet, basically. And one thing on Strabo Micro, we're using Strabo through an NSF network, and we just got a 10-fold increase in storage on that network. So we're going to be opening up Strabo Micro for uploads pretty soon.
It's actually, I wanted to add something to this discussion on instruments and having access to metadata that are relevant. I'm working with a group in the planetary sciences and astromaterials measurements, and it's becoming a requirement that raw data are archived for these astromaterials measurements. And There's a big problem with a lot of the instrumentation just providing the raw data in a proprietary format. So I think a broader discussion with the manufacturers on making their interfaces open and not moving beyond proprietary formats is really important in this context of the world moving to FAIR principles and open science. So it's a big issue, and I think we should unite forces there to have a substantial voice.
I just posted a link to DTSA2 software. And actually what they've done at NIST, they back engineer a lot of spectral data files. So you could actually open a lot of spectral data files from microbeam instruments. So I think it's a great start and a great platform because it's a kind of a government organization that they can actually have a lot of power in the funding cycle to open up all this instrumentation.
Also wanted to add that we're currently planning to get a workshop together on imagery in the analytical sciences. There is a lot of demand on EarthChem right now to store backscatter, SEM images, and so on. Same for the astromaterials data system. And we know there are repositories out there that have expertise in this. Some of you may be familiar with the Digital Rock Portal as one of them. StraboSpot, obviously, and Strabo Micro are going this way. And I think we are really at a stage where we need to talk about standards there as well, and the challenges of storage and transfer and analysis of images. So I hope, if you're interested, would be nice to know about it. Just let me know, and we'll include you in the discussions where we have started with some of the people to get that done.
Just a quick addition for Strabo Micro, there's actually a way to enter and document instrument data and instrument types. It's sort of built on something that was done at EarthChem over a decade ago. But anyway, you can enter in anything from BSE to just microscope, plain old microscope information. And again, that's been put in mostly for the microstructural geology community and petrology communities.
All right, well, thanks for your feedback. So I tried to summarize some of the things that you guys just posted, and I'll ask for Doug to discuss one of these points, but I think overall everyone, yes, we love it. We've tried it, we love it, or we haven't tried it yet, but we want to. So that's all really good feedback and exciting. There was the comment about needing money for students at universities to fund those, and Doug talked about that a little bit. People just recognizing maybe I haven't used it, but if it's user friendly and uses best practices, yeah, I'd like to give it a go. So that's good. And yes, they do use the best practice guidelines. Great at streamlining my workflow, both in the field and now in the lab with Strabo Micro. Good for keeping everything in one place, someone said. And then Doug, if you could talk a little bit about offline files. There was some concern about, so that is also really an important part.
Yeah, no, you can use it completely offline, and that's typically how people will work during the day or during a week or two in field season. They'll work offline, collect data onto a mobile device, and then upload it when they get back. So it's ready to go. That's one of the fundamental design criteria, is working offline and importing custom maps, backgrounds, etc. I also mentioned that there is a standalone server for Strabo Spot. You can basically download that and run your own Strabo Spot server. And then you get the capabilities of custom imagery. So for example, if you're in the middle of nowhere and you had collected drone imagery, you don't actually need the internet connection to the outside world. You could just do it autonomously and remotely. And I guess the last thing with all this is that one of the things that we've worked really hard at the whole time is making sure you could back things up. And so there is the ability on any device to back up to an SD card or a computer, or some people actually will work in the field on the tablet and then just back it up to their phone that they're carrying around at the same time. It's all meant to have that level of redundancy and backup as well.
All right. Thanks for that, Doug.
Doug, can you comment? Sorry for interrupting. Doug, can you comment on hardware needs? Because I remember something about you need to get the iPad with certain like specs.
So for Strabo version 1, which will be phased out within probably a year and a half, it'll run on any Android or iOS mobile device. Strabo 2 right now is running on or released on iOS only, but soon will be running, it runs on Android. We just haven't done the rigorous testing that we need to before we release that. So that'll be out, I hope, within a month. But at this point, the user base was really vast majority were tablet users. So we, in the Strabo 2 design, have put it to tablet. Hopefully will be funded so we could go ahead and put it down to a phone-sized device eventually as well. But I hope in a month, any tablet you might have would work on it.
So, and Doug, just clarifying and adding to that, on the Android or iOS like software versioning, you know, so many apps now are requiring newer and newer versions of the OS itself in order to even run. And like my university, for example, we have a whole fleet of like 20. We got a grant to get about 20 of these, iPad minis, and they can't go past iOS 12.5, right? And so, and if Strabo were to continue to run on 12.5, they would still be usable as field devices.
Well, so Strabo 1 will run on those without a problem. I haven't encountered that too much. We have about 40 iPad minis that we use, and they seem to keep updating for me. Mm-hmm. To the latest. I mean, I just updated about 20 of them the other day to the newest OS.
Yeah.
But some of these are 4 or 5 year old tablets, so I'm not quite sure what the problem there is.
I think it may be something to do with maybe the specific development tools that are in use for some apps, and that are start tying things into newer features of the newer OSs and then they won't function without those features, so therefore they won't run on older devices that don't support the newer OSs. So if the Strabo development doesn't need those things, then that would be great, because then it would still remain functional on older.
I'd like to hear any issues you've had with that in running it on older OSs, because that's not something I've heard about. So
yeah, it hasn't been an issue yet.
Oh, okay.
Hoping to ensure that it doesn't become an issue anytime.
Well, yeah, we're working to keep that to be a non-issue. I guess the other thing just to mention is between the earlier version and the second version of Strabo Spot, those are completely compatible. You can upload and download data to either version and no problem working with it.
All right, appreciated. Thank you guys for that. those follow-up questions. So some other things that people have, let's see, I'm back one still, Steve, that came up with was love the stratigraphic builder function as well as the fence diagramming abilities. Some say it may be hard to work into their workflow just because you have your own system, and yeah, we all recognize that. But maybe going forward, this is something we should be doing, or that those people should be doing. I'm one of those people for sure. And then an important topic is just adding time in the field when it's critical. So perhaps eruption response, this might be complicated, but you can work this into your workflows and think about ways to make it. It's supposed to make it easier for you. So if you have everything set up ahead of time, it may actually not take as much time as you think. Okay, so let's.
Christy, can I just add to that? I've been using it for a long time, and it makes it so much faster in the field that I virtually stopped using paper notes ages ago. So it actually speeds things up in the field very much.
Yeah, that's amazing. Okay, let's go to the next slide, Steve. Okay, so question 5, it's along the same lines. Our session 3 was an example of integrating the best practice guidelines into an existing well-known and large data repository, so EarthChem and CSAR. And again, we're just looking to gauge your thoughts on using this avenue for uploading your data, using the templates that were developed for this purpose. We also recognize that EarthChem is a US-based repository, not that it only contains US data by any means, but we understand that people may be restricted to using other repositories in their own countries or whatever the restrictions are. So we're just asking if there's other repositories that should incorporate the best practices to make it easier or even possible for you to upload your Tephra data. So kind of two-part question there, but if you just go ahead and indicate question 5 and give us your thoughts on that.
I think in that context, also important to emphasize the existence of the EarthChem portal and the PetDB database, which is different from the repository and really builds this integrated synthesis of geochemical data where we just incorporated all the Tephra data from the East African Rift, the EarthD effort. So if there are data in repositories in other countries or other programs or agencies, they could still be linked up with the EarthChem portal to provide access to a fully integrated and comprehensive database of Tephra geochemistry. We're actually going to be talking with the AVO this afternoon and linking the AVO geochemistry database up with the EarthChem portal. So just one example.
Steve, maybe we can show the rest of the slides. So if people have to leave early, they can take a look on the questions and maybe submit some answers. Sure. And we probably will stay a little bit longer today.
Yeah, and I think, yeah, we're doing this. And this one, we have some partners we've noted already in trying to do some implementations, and it would be really, really useful to get a better idea of what the global landscape is for other data systems that people are using across the world that we might want to be part of this bigger effort, kind of a much larger collaboration, so that we can put these things all together and make all these systems work better for the community.
There is also, just as a for your information, there's a global effort going on right now called One Geochemistry, trying to develop standards for data exchange among geochemical data systems. sort of technical protocols for doing that and vocabularies and so on, with participation right now from several European countries, from Australia and from the US. There's in that moment, I can just advertise there is still the possibility to submit abstracts to Goldschmidt, and there is a session on data resources in geochemistry that would love to get some more insights into other available databases or tools and so on.
One thing I'll add is that EarthChem started as an international effort. So it started between the US, Germany, and Japan. So it's been international and serving internationally since it started.
And there is still very close, actually closer collaboration now going on with the German-run GeoRock database, in that we're really integrating our operations quite deeply.
Kirsten, there's a question or a concern in here about EarthChem not accepting physical data, grain size, componentry, other things, that it's mainly for geochemistry. Can you comment on that and maybe the future of EarthChem, the vision?
It's actually is a lot of other sample-based data already in the repository, but clearly we can't accept physical objects, samples, and so on. That's not within the scope, and there is no space or curation capacity available, unfortunately. I'm sad that Raleigh has left already, because that's obviously a big topic for NSF, that there needs to be a repository for the samples to survive in the same way the metadata about the samples survive. And if you have read the Earth in Time report, there is a whole chapter on the need for having such a community sample repository.
You mentioned that we can discuss later with him if we have any workshop outcomes that really
that would be really good.
Yeah, we will organize something like this in a smaller group, but we will compile everything from the workshop, because that's a community really input here.
So we've put up the next question, number 6. This is regarding legacy data. We had some discussion of this previously. Marcus, would you like to add on?
Thank you, Steve. Andre, how are we doing for time?
Originally, we tell everybody that we will finish an hour and a half. So we are approaching it in a minute. But if people can stay another half an hour, let's try to finish everything. We still have 3 more questions to discuss, right?
Okay. And so let's question number 6. And these ones should go faster, I would think. Is there a way to influence funding agencies to make legacy data recovery and reuse a greater priority? I noticed some people are already answering, so that's great. So maybe this one and the others are going to go a little bit faster. And then the final question is just a very general one. But these are very specific ones that should help us all to think about how we can get some of the data out there that aren't currently, we're not able to get back out in the public realm that much.
And it's also input here from a NSF reviewer, so proposal reviewer's perspective, because quite often you might pay less weight to the research question and really pay attention to this legacy data value if you're reviewing those proposals. So that's something we can discuss as a community as well.
Mm-hmm.
I think it's really important to connect such legacy data recovery to new science questions. We were currently at EarthChem supporting a number of these sort of data rescue activities. One is Antarctic geochemistry of samples that are curated at the Polar Rock Repository. One has been the Earth-D effort, and one is in conjunction with the Converse, the community network for volcano eruption response, who need better coverage of US volcanoes with respect to data. So if you can link it up, I think there are ways to enhance these legacy data rescue efforts.
I would like to add to that. There's a lot of legacy data, ongoing data generations, and samples that have been collected for which there is no publicly visible indication they even exist at all.
Wow.
Not at all. I mean, it's not in a repository. There's not a publication. There's absolutely nothing. And some of these are just going to sit there in spreadsheets in labs absolutely forever, right? Unless we have some efforts to specifically get them into repositories. And some of those data, there's no way to really justify getting it in for a research question, because the people with the question don't even know where this data is or that it even exists. It's very different than I have a new research question and there are publications from the 60s and 70s and 80s on that topic that have data, and I want to gather that and put it in a repository. This isn't even discoverable to even know that you'd want to put it into such a compilation in the first place. So that. And so that's
Steve, can we go to the response slide? I think there hasn't been a lot of responses, so I think it's okay to summarize these now. And folks, even after we summarize, if you want to add a response, that would be great. So in terms of helping the funding agencies to get interested in helping us with using legacy data, link the legacy data to new science questions. A big thing, of course, make it obvious that you're going to answer a big science question. One really good point is that it's a lot cheaper to use legacy data, so that should be a motivation to a funding agency, that it's a lot cheaper to use legacy data than to go back out in the field and do field work and all that. One idea was to show that there's support from a tech company that would be interested in these legacy data. And one can imagine ways in which that could work. And then somehow show that a whole high-profile publication could result from the use of legacy data.
Yeah, and I think,
oh yeah, go ahead.
Following up on what I mentioned before, we probably do have labs that have some miscellaneous samples that have been analyzed, and we don't know where they came from, and another lab has the same, and another lab has the same. And right now, some of those may actually correlate to each other, right? But we don't know it, and we aren't in a position where we could even find that out unless we have people going and talking to other labs. Like, well, what is it you have hiding in those dusty boxes that might match up with something that I have hiding in those dusty boxes, right? How do we get past that and stuff? Okay, so question number 7. This is following up on some of the previous discussion on data ownership and credit and all of those kinds of things. Citation is mentioned here, data citation is in particular, embargoes. We've had some talk about community practices, community ethics on some of these things. So here's an opportunity to expand on that, and perhaps with some more targeted responses on the issues around data ownership. So here's a summary of some of the key responses. We've seen quite a lot of making sure that credit is given in one way or another, or permission is obtained, and including data producers as co-authors on papers that result from their data. It came up several times. And certainly there is potential here for some kind of community statement. We see things like major scientific associations will have some kind of official statement on a topic that's a common thing. The Tephra community could do something like that on recommendations for community use and reuse of data and sharing of data and ethical expectations around that kind of thing. That certainly could be done.
Okay, we're coming into our last question. We have room for others at the end, but this is our last formal question, and it's a big one. It's kind of loaded. How could a global Tephra system, or what should it look like? So we're looking to the future here. Do you see dispersed user-driven systems? Are you looking for something that's bigger, like a monolithic system for holding everything? Or keeping things as they are? We're really just trying to get a feel from you guys to see where you're at and what you're thinking. There also might be things like fit for purpose databases for geochem or physical characteristics, or do we want them all together? Things to track our processing steps, things like that. And then the question about what infrastructure is needed. So we're talking about things like physical infrastructure, repositories, servers, digital infrastructure, software tools, as well as human infrastructure, people, training, professional assistants, things like that. So yeah, if you guys can put in question number 8 and just give us your thoughts on this. Again, we know it's loaded, but whatever you can think of, I think it's going to be valuable. So much appreciated.
Steve, you want to give example about shared developers that EarthCube is always talking about?
Oh, yeah. So there was an idea that's come around in discussion a few times. There are a lot of projects that have been run to build tools. Some people, of course, are a little bit computer programming savvy and are able to build some of their own things. We also have a lot of other geoscience people who have gotten together in teams and had grant funding to support projects to build various kinds of tools. But a lot of these don't necessarily hire formal experienced developers. And some of them do, but then they only need developer help. Maybe they need 1 month of a developer's time. And then there's another project that needs a month or 2. And well, how do they find the staffing that they need? How do they hire? How do they find a developer, a software developer who maybe has some prior experience with the geoscience community, so that the communication barrier to trying to explain to the developer what needs to be made and how it needs to work so that it's accessible to the end users. If somebody has never done anything with geoscience before, it's a little bit harder to communicate that and have the end result really be what is needed. So there's been some talk about that and trying to figure out, well, how can we have maybe an agency might hire a few people and then they are available to projects. So there's kind of a professional staff out there, kind of like what we have with data repositories. In many cases, there are curators who are hired long-term to help people get data into these systems. Could there be software developers who are hired in a similar way to help projects get software developed and improved?
And another thing to add here is, does it look like Strabo plus CSAR plus EarthChem is a good system? And so we're actually pretty close to something that'll supply our needs.
Perhaps I should also mention there is another project. Some of you were here for the previous session, and there was a slide that came up. I think it might have been a part of Lucy's talk, where it had things like Strabo and CSAR and EarthChem, but it mentioned a few other things. Another one that was on that slide is something called Sparrow, which is another one of these data systems that's under development. It's still, it has some implementations that are working, but in many ways it's still a fairly new and under development system that needs a lot more work to get it to where people might want it to be.
Yeah, I think it was the very first question where or one of the questions in the chat, I don't remember, where I responded that it is actually, really important now to focus on the support, on the funding of interoperability development. We have systems in place, but they all need to talk to each other, and that does require quite a bit of work of aligning, the interfaces, aligning vocabularies, and so on. And we are pretty close. I mean, we've had a session last year at the EGU about this pipeline of geochemical data that had Sparrow there, had Strabo Spot there, had EarthChem CSAR, and a number of other systems actually, all kind of trying to envision how data can flow through these systems and into a common data access portal. We have just built for, I mentioned Converse as this volcano eruption response network. We've built a volcano portal for them where we're linking information from EarthChem, UNAFCO, IRIS, CSAR, all, you can go to places, to volcanoes, you click on it and you see all the data that's available in all these different systems, because they all use a standard protocol of making these data available. So I think there are lots of developments going on right now to build these capabilities where different systems can deliver their data to sort of community-specific portals, like Tephra could have its own Tephra portal to different data systems.
Yeah, so we would be having, in that vision, there are multiple tools, and they would, each of these different tools would work in combination, and they would all together cover the whole workflow. So we would have some tools covering the field data, some tools helping to capture all of the details of the laboratory workflow, others helping to archive the results of the research, others helping to make it possible for people to find data, to do searches by volcano, by chemistry, by any number of other things. Does that cover everything that needs to be done? Or are there other pieces of that infrastructure that we haven't identified?
I think Tephra would be a great use case for doing something, for building something like that.
One of the participants raised the hand. So if you want to talk, you just unmute yourself and you should be able to talk. Unless you did it by mistake, then it's okay. Don't worry about that. It happens.
Can you hear me?
Yeah.
Okay. Yeah, I just wanted to add in another suggestion there, similar to possibly having a funding agency provide one person for a month. There are companies out there that specialize in database building and management from the back end to the front end. And if you're willing to hire one of their techs or pay them essentially for one of their developers, you can have them essentially on retainer all year. They can also act as a data entry person. They act as your IT troubleshooting person in case a server goes down or you want to change the database. Let's say you instead of having one person for a month and you build up to what you want, and then 6 months later, like, oh, we really should have done it this way because that's how we want to interact with the information, or, oh, we need to add this new information. Like, that person's always there to do that for you and do that work. And it may not be that you need them a whole year. Maybe you pay them for half of their time for the whole year. But I think using companies that already exist and have this as their core expertise could be another way to do that instead of through the funding agencies, because that way it's tailored to our needs as a Tephra community. So I just wanted to throw that out there as another option.
Thanks, Carolyn. I assume that was
If I can throw in a comment here, I saw in question 8, statistical analysis functionality, R plugins. One outgrowth of the EarthCube effort has been trying to support and regularize the use of notebooks, Jupyter notebooks and such, to create scholarly products. And so that's something else that can be done. Those can be shared. And I don't know how many people on this call have used them, but it's another pathway you could take.
Right. Yeah, that's a good point, because there a lot of research is using software tools and code like notebooks, and there are efforts underway to make it so that something like a Jupyter notebook was developed for a research project could also be a citable, reusable output, just like the data is, and also ways to archive packages of the code and the data, because that would be kind of the ultimate way to get reproducibility, where somebody could go and rerun the code with the same data and see what the output looks like, and maybe tweak some of the parameters in there and see how that changes things.
awesome. All right, so I tried to compile some of the comments, and let's see. So, I mean, I think a lot of people think that, yeah, the monolithic vision would be a dream, but probably not the most realistic, although it would be the most consistent. If it was just one system using the best practices, then everyone would do it the same way. There are lots of comments about trying to create something like a Tephra portal where you could access distributed systems. So some of these things are kind of the same here. One suggested that there's a monolith that kind of holds the major data, but that there are user-driven systems that can link to the monolith. And so sort of depending on, a bunch of smaller systems linking to something bigger is a good idea. Doug just talked about, yeah, the add-on tools for plotting or statistical analysis or R plugins. That's a great idea. Makes things a lot simpler for users to be able to, look at those data quickly and analyze them online. Making sure that the systems are user-friendly, easily searchable, and also maybe just contain the basic information. Maybe not everything, but have the basic information in a big, monolithic system. Obviously, yep, the systems need to have long-term support, so we don't fear of putting our data in there and thinking it might one day just go away. Correlation tools, that kind of goes along with the plugins being part of these systems, making them easily searchable based on elements, and then, yeah, just making sure that we can hold all types of Tephra data, not just a couple of them. So I think that's been, a big part of this discussion is working on developing systems that can hold more multi-parameter information, and Tephra is just one of those data types. It's a problem. There's just no system to date that holds everything. Even at AVO, the Volcano Observatory in Alaska, we have to build things in modules. It just takes a lot of staff time and development to do this. And so we've always had a monolithic vision, but we build it step by step, and it's been 20 years and we're still working on modules. So it's a big deal. Okay, Steve, could you move on to the next slide? We're basically, at the end of the workshop, and I think this has been tremendous. The feedback has been incredible, and we're so excited to collate this information and to make it available to everyone and to use it to help us move forward, and it will definitely do that. So be looking to your email and to the website for more feedback there. But if there are any topics that we missed, I know there are, please feel free to use question number 9, to respond to anything that you think that we need to think about or work on or focus on. So you can do that in the poll, and obviously you can raise your hand as well and speak now. You can also use the listserv. Go on to the next slide, if you will. Yeah, you could use the listserv, or you can contact any of the conveners here to ask questions, and we'll definitely get back to you. We're trying to keep the listserv for the workshop focused on workshop topics, so that Google group, please try to focus that on the workshop topics and not other kind of general things. However, there are a couple other listservs that you could use, and Marcus or someone, can you put those links in the chat, or I can do it in a second here. There's the Tephra listserv, and there's also the volcano listserv. We'll add those in there. We encourage everyone to join the IOFSE Commission on Tephrochronology, or COT. The link, we'll put that into the chat as well. There's a new membership form that recently came out. That's a super active group, and it's recently moved to IOFSE, and so becoming a member, I think, is going to be really important. And then we also plan on sending certificates of participation in the coming weeks. So if you need that to be customized in any specific way, you can let us know. Otherwise, we'll be sending them to all participants, and if you need that to be different and somehow, just let us know. But anyway, thank you all so much. And if there's any final topics you want to bring up, go ahead and add those to the poll, or raise your hand, or any of the panelists want to say anything, go ahead. I'm going to find those links real quick.
Thank you, everybody, for attending and staying a little longer. We lost maybe 10 people only the last half an hour. That's good.
Excellent. All right, putting some of these links in here. Now. And I want to get the membership.
You still want to get a feedback for the last other part, right? See if we get any.
Yeah, yep, for sure. Okay, there's the COT membership in the chat. So coding is coming up again, statistical analysis. Yeah, that's really important. With the new postdoc that we have at the USGS here in Alaska, this is one of the reasons we selected the person we did, because he's got ability to develop tools, and we're really excited about that. So we saw that too as a really important part of the large tephra producing eruptions project in Alaska.
One thing I'll add here to one of the responses to A is in the past, we've had plugins for QGIS for StravaSpot, and we're working with Christie's group now to try to resurrect that. So that would be on open source and free software.
Awesome. Yeah, that's great. One question that came up to us earlier before this, and we couldn't quite figure out how to integrate it in, but the question was, can we provide an update on the status of the 4 INTEV glass standards? And I don't think that we have a response to that right now. Steve, can you comment on that, and we can get back to people, or Britta or someone else?
Sure. So there have been the original, I guess, well, it's not really the original, because there were some older ones all the way back into the 90s, but the INTAV interlaboratory comparison course, Intav is now caught, published back in 2011, had 4 glasses. And there was a Lippery obsidian, a Old Crow Tephra from Alaska, and another more alkaline Tephra from British Columbia, the Edsiza sheep track Tephra, and also the Lockheed, famous Lockheed fissure Tephra. To those, it was intended to give us a range of compositions, as well as nice big pieces of glass like you would get with an obsidian, but also some Tephras with kind of real world issues like being very bubbly and hard to fit a big beam on and things like that. So those are still being distributed. I've been getting 2 or 3 email requests a year for other labs asking for those, and I've been trying to fulfill those as I can. Some of the materials are in better supply than others, at least the original splits. So I think there's plenty of the obsidian. I don't have that much Old Crow, but Brita, Old Crow, there's lots of Old Crow in Alaska.
I think I've got probably several kilos.
So that wouldn't be hard to get. The sheep track one, for small amounts of distribution, I don't think that one's too hard. If I recall correctly, that what we sent out all came from a very small, a relatively, was it one class? I mean, the Lockheed one was definitely all from one class.
Yeah.
I think, in any case, the sheep track one, there isn't quite as much availability of that, but I think we can continue distributing that. The Lockheed, I still have a little bit of that. It's not the exact same split. So what we originally distributed went through a little bit of purification to reduce the amount of phenocrysts and other crystalline material in there. So it was more glass with not as many inclusions. What's left is a little bit more or less bulk, and there's still plenty usable material. But again, there's not as much of that. I know we've been trying to pursue getting some more lot material.
Yeah, we at the University of Alberta, we have loads of everything but the Lackey. So and that we're working with Thor to try to replenish that one. But I mentioned this earlier to the panelists, and I just want to say that as a positive note, something I've noticed over my time, I started my master's learning Tephra chronology with John Westgate in 2004. And it's just been an absolute sea change in terms of data reporting, consistent standardization. I just was looking at a paper randomly about some Marine Corps where Tephras were analyzed in 2015 from Fogo Island, and the data was all reported, and they used Lipari obsidian as their standard. So I was able to directly compare, and I couldn't even imagine that happening like 10 years ago. So I think I just want to point out the community has made huge strides already that are incredibly beneficial. So I think we're actually well on our way.
Yeah, I should say also on the reference glasses or secondary standards, I know we use different words for those. The quality control standards that we can share amongst labs so we can compare our methods and check the quality of the data. There is also a set of those, a little bit bigger set of those under development that's intended to be both major and trace elements. And with the expansion of trace element analyses for glasses, particularly Tephra glasses, those are going to be really important. Some of those have been distributed out to a number of labs for that initial testing and data gathering phase leading up to reporting best estimates of those glass compositions. That's still in the works.
All right, well, again, thank you everyone. This has been a really successful session, and the whole workshop has just been tremendous. So thanks for all of your support and for being here.